solving basic math equations. That's what we're working on today. Because every math problem has something that you don't know and you're trying to figure out. This unknown could be part of the answer, or it could be part of the problem, and we just have to figure it out. These are called variables when we don't know something. Well, we use variables when we don't know something. We put variables in when we're not sure of an answer. So, most basic thing, you guys have been doing this since you were like, I don't know, 2? When you have an equation and you say like, 4 plus 2 equals, and there's just a box there, and that's where you put your answer, that is an unknown. That is the variable that you're using. Then when you get older, they just make it a line, right? And then it's just a dash. You have to put the answer there. Sometimes they'll put like a question mark, and you have to solve it. So in this answer, what's 4 plus 2, guys? Yeah, it's 6. So really, this question mark, it stands for 6. It equals 6 because that's what we figured out the answer is. That's what we're going to look at today. In math, there's things like question marks, there's things like boxes, there's things like random letters and numbers that we use as variables. First, you're going to watch this video. It's about 7.5 minutes, and then we'll keep talking more about it. All right? If you have any questions, remember to pause, stop, and ask me.
Symbols are used to help people communicate. They are signs or objects with meanings that everyone knows. For example, traffic signals communicate information to drivers and pedestrians. At an intersection, a word or symbol tells you when it's safe to cross in the walk, don't walk signal. A red octagon is the universal symbol for stop. A yellow diamond shape means caution. And a circle or square with a slash means don't or no. Getting to know these symbols and what they mean is important for learning about and getting along in the world. In the mathematical world, symbols are used in several ways to represent numbers, special quantities, and values that are unknown. Numbers have a written name. For instance, the numeral 5, the Roman numeral 5, the word 5, and cinco in Spanish are different symbols that stand for the same quantity, this many. Special quantities are also represented by symbols, like pi. No, it's not a round thing with flaky crust. This is the Greek letter pi, which stands for a little bit more than 3.14159. It's a number with unending and never repeating decimal digits. 5 and pi are both numbers, constants, values that don't change. Symbols can also stand for values that do change under different circumstances, or that we haven't figured out. These are called variables. We can use a question mark to represent a variable. A few examples of the use of a question mark are 148 plus 39 equals a question mark. 27 divided by 3 equals a question mark. Or the air temperature is a question mark in degrees Fahrenheit. Like a question mark, other letters or symbols can represent numbers that vary or that we haven't figured out yet. This allows us to have more than one at a time for different quantities. Let's look at some examples of how symbols can represent variables. Fruit comes in all shapes, sizes, color, and quantities. We all know that fruit is good for you, and these chimpanzees seem to know the value of a good treat too. Here we see a tree full of bananas, but we don't know exactly how many bananas there are. We can express that unknown quantity with a question mark when we write it in a number sentence. The question mark is the symbol for a number that we haven't figured out yet, a variable. The unknown quantity in that same bunch of bananas can also be expressed using a letter as the variable. X bananas, for instance. You can use any letter as a variable. It could just as easily have been Y bananas or B bananas. Of course, if we know how many bananas there are, then we would use the actual number, like 89 bananas. But until we know the number of bananas, we use the variable. In this case, the number of bananas is truly variable. It gets less as they're eaten. Another name for a variable is the unknown. In the remote wilderness of Alaska, there's an annual gathering of caribou, which is so enormous it seems at times that the land itself is on the move. Every year the vast herds, hundreds of thousands strong, make an epic journey hundreds of miles long. Like most populations, the size of the western Arctic caribou herd fluctuates. The size of the population can be expressed as a variable. For example, in 1979, the population was estimated at 121,000. The population grew steadily over the 20 years between then and 1999 to an estimated population of 430,000. If we let C stand for the estimated number of caribou roaming the Arctic, then we can say that C during that time was between 121,000 and 430,000, taking different values at different times. At the height of their dominance, 30 million to 70 million bison roamed freely throughout the prairies of North America. But 100 years ago, bison were on the brink of extinction due to hunting and changes to their habitat. Now, they're making a fragile recovery. More than 350,000 are alive and well in North America, most living in zoos or on private farms. But about 10,000 to 20,000 of the great symbolic beasts graze peacefully on the wild prairies. In 1820, buffalo numbered upwards of 70 million. Then, their numbers dropped alarmingly low to only about 1,500 animals in 1890. Legal protection of the North American bison helped restore their population to the numbers we have in 2004. In this chart, B stands for the number of bison. B takes on varying values for different times, first decreasing from 70 million to 1,500 between 1820 and 1890, and then increasing from 1,500 to 350,000 between 1890 and today. The word soup comes from the English term sop, meaning a piece of bread soaked in liquid. The word soup replaced sop at about the same time that people actually began serving soup without the ever-present piece of bread to sop it up. At this soup factory, they transformed chicken and veggies into soup in a can. Here we see a large quantity of soup, canned, cased, and ready to eat. What if we want to know how much soup there is in any number of cans? For example, the factory might need to know how much soup to make to fill a certain number of cans. Let's make S the variable for the total amount of soup. Let N be the variable for the number of cans we're considering. We know that each can contains 10 ounces of soup. So the total number of ounces of soup, S, in the cans is 10 times the number of cans, N. Using the variables, that can be expressed as S equals 10 times N. That's the mathematical relationship between the number of cans, N, and the total amount of soup in ounces, S, in them.
Okay, so I know at the end there that got a little confusing. They were using two variables in one equation, and that's a lot for our brains to process right away, especially this early in the morning. But it's just showing that you can use letters and variables to express different things. We're not there yet. We're not ready to use two variables to express an equation with only one number. For us, that's completely unknown. We don't even know how to find the answer to that. We're working on one variable right now, guys, just one. All right, so let's go to the next slide and see what we're working with. Oh, Miss Weber lost it. There we go. the first thing you need to do to solve a math problem is figure out what is known and what is unknown. In the problems below, the question marks represent the unknown. Of course. The parts of the equation that you know are called known or constant because they are not changing and they're right there. You see them. The parts that you don't know are the unknowns, and they're also called variables at times. So in this equation, we got a question mark plus 3 equals 4. Come on, guys. What plus 3 is going to equal 4? You got it. So the question mark for this one really equals 1 because we can replace the question mark with a number 1, and we find that 1 plus 3 equals 4. All right? And then in the next equation, it says 2 times 5 equals question mark. Well, what does the question mark in this one equal? It's not going to be 1 again because it's a whole new equation. Every time there's a new equation, the variable changes. Even if the same symbol is used, the answer to it is going to be different. All right? So 2 times 5 equals 10. So the question mark here represents a 10. And then in this third equation, we get a 14 divided by question mark equals 2. Well, what's 14? What can you divide 14 by to equal 2? 7. That's the only possible answer there, guys. So the question mark equals 7. Variables are used to represent the unknown in any equation. Any letter can be used to represent a variable, but the letter O should be avoided because it represents 0. So you don't really want to use O when you're writing an equation. Like any equation, when we had this 4 plus 2 up here, we could have said equals X. We could have said equals Y, Z, B, A, I don't know. You could do any letter of the alphabet. But what this is telling you is don't use the letter O. Because what happens if Ms. Farmer puts the letter O right here? That looks like 4 plus 2 equals 0. And that's not accurate, all right? So try to avoid the letter O. Use other letters, any other letters in the alphabet, just not O, all right? So here we see, instead of the question mark, our variables have been replaced with letters. X plus 3 equals 4. Hey guys, guess what? The X is still 1. It's the same equation. We just replaced the question marks, which younger kids use, with letters, which older kids use, like you. 2 times 5 equals, yup, still right, it's 10. The A is now 10. 14 divided by B equals 2. Well, the B equals 7. Come on, guys. It's the same thing. We're just changing it around a little bit. All right? Again, if you're not understanding something or you have a question, what are you going to do? Stop and ask me. Next slide. Let's erase all of this stuff. So it says, now that you know how to replace the unknown with a variable, you need to be able to figure out the value of the unknown. To do this, you first need to ask yourself, what do I multiply the constant by to get the answer? For the following equation, you would ask, what number do I multiply by 9 to get to 45? So if you have your multiplication charts with you, you can go 9 and just go over until you get to 45 and then go back up the chart to see what your multiplier is. Or you might just need to know it, or you can count by 9s. 9, 18, 27, 36, 45, 54, oh wait, I missed it, 45. How many did I count to? Very good, 5. So 9 times 5 equals 45. So in this equation, the y really equaled 5. Also, do you notice something weird about this? They're not using an x anymore for multiplication. They didn't say 9 times the y equals 45. Why do you think they didn't do that? Yeah, it looks like these are two variables. So instead of writing the letter x for multiplying, they used a dot. Alright, it means the same thing, but now it's not going to get confused with an x like a variable might. So it just makes it a little bit more simple. A little more confusing because it's brand new, but more simple in the long run because now you don't have two variable looking objects. We just have one variable and a multiplication sign, okay? We're going to do these ones together. Now, so we have x times 3 equals 15. What 3 times is going to equal 15? Remember, we can do just multiplication problems. We can use charts. If I have x times 3 equals 15, I know there's going to be 3 groups, and my total is going to be 15, right? So here's 1, 2, 3 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I made 3 groups. My total is 15. Let's count how many are in each group. 1, 2, 3, 4, 5. This means my x should be 5. I'm going to double count these ones just to make sure. 1, 2, 3, 4, 5. All right, so far so good. Just triple check. 1, 2, 3, 4, 5. My x should be 5, so this equation should be 5 times 3 equals 15. Let's click on it and see if we're right. X equals 5. Look at that, guys, we did it. Woohoo! All right, the next one says 4 times y equals 8. This farmer's going to change her marker because right now the background's green and that one was a little hard to see. And I'm also going to go to the other side. So if I have 4 times y equals 8. So I need 4 groups, right? 4 groups. My total is going to be 8. 1 group, 2 groups, 3 groups, 4 groups, total is 8. 1, 2, 3, 4. 1 in each group. You have to do 1 in each group before you go to the next row. Alright? You can't put 4 in one group. You're going to get off. Alright? 1 in each group. 1 in each group. When I count it up to 8, I have 2. I'm not going to count all of these. I think you guys can see. That's 2 there. Another 2. Another 2. Another 2. So my y is equal to 2. Because I can replace it in my equation for 4 times 2 equals 8. I guess I shouldn't have moved sides, huh? Let's double check it. Look at that, y equals 2. The next one says m times 5 equals 25. What do you think m is? How many groups do we have? Let's split them up, count them out, put them into their circles, into their groups, into their arrays, and see what we get. I have 5 groups. Right there tells me that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. This farmer's stop got a little off there because my circles got smaller. I'm sorry. So, how many are in each one? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Because it's going to be 5 on all of them. So our m is equal to 5. So we can't write, but our m is equal to 5. Let's double check it. Are you understanding this? I hope so. We're not going to do these last 2 together because you have them on a different activity already ready to go for you. The last page of this takes you to the activity that you're going to be doing. Alright? This is already all on your Seesaw. I'm talking to you through YouTube so that you can sign back into your Seesaw and get this completed. The activity is a whole list of variable problems. Right? Whole list of them. I think there's just 10, just those 10. You're going to solve these. Alright? Not super hard. It's on your Seesaw activity. Solve it there. Don't miss this problem. The first problem is very important. It says in your own words. Your own words. Not what I said, not what the computer said, not what the screen said. In your words, explain what a variable is. It should be written in a full sentence, guys. Math is no reason to slack off. Full sentence, write it there. And then here, you just have to tell me what each variable is. Any questions, comments, or concerns? Remember to message me, question me, so that we can fix all the kinks that we have in our lessons. Alright? That's it for now. Get to work on that. See you guys later.